All right, it's recording, so let's start. So it's all about just a notation today, right? How to represent this relation, this function, which is a special relation, in different ways. So we have a graph for number one. And the first thing I'm going to do is write the relation. So I have negative 3 and 2. Oops. Negative 3 and negative 2. That's my first point here. The second point is 0 and 1. And the last point is 3, 2. Makes it easier for you. Write x and y on top of each so you know who your input and outputs are. I create a table. Input, output. Right, so that's my y, that's my x. So I have negative 3 coming in, negative 2 coming out. I have 0 coming in and 1 coming out. I have 3 coming in and 2 coming out. Right, the same points. Mapping. So, right, the mapping is like this. Input, again, same thing as a table almost, right? So just except that we don't repeat numbers. Output, if you want to go ahead and write domain, right? And range. So domain are all your input values, your x values, and the range are all your y values. So domain had negative 3, 0, and 3. Your output was negative 2, 1, and 2. So negative 3 went to negative 2, 0 went to 1, 3 went to 2. And I'm going to write domain here. Right, our domain was negative 3, 0, and 3. Our range was negative 2, 1, and 2. Is this a function? Yes, because for every input, there's only one output. So when you, and I used the word press, right? When you put negative 3 in here, the only thing that came out was negative 2. When you put 0, what came out was 1. When you put 3, what came out was 2. So for every input, there was only one output. So this is a function. All right, so let's take a look at this one. I'm going to plot the points. 2 and 3. Negative 3 and 2. 4 and 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Somewhere up here. And then 20 and 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So 21 will be right over here. I know in class I said you can shorten it, but that's our graph, right? So I'm just going to go like this and extend it. So I forgot y, my output. This is my x, which is my input. So let's do a map first. So we had 2, a negative 3, a 4, and a 20. Negative 2 went to 3, negative 3 went to 2, 4 went to 7, and 20 went to 1. Right? So for every single input, there's only one output. What am I missing? Table, yeah. Oh, I forgot. This is my input. This is my output. Go ahead and write, this is my domain. This is my range. My table, x and y, input. And again, I'm being repetitive here because I want you to get used to knowing that x is your input. It's also your domain, right? Y is your output, also your range. So we had 2 to 3, negative 3 and 2, 4 to 7 and 20 and 1. Is this a function? So when you pressed, the answer is yes. When you press 2, what came out? A 3. Did anything come out when you press a 2? No. Negative 3, what came out was a 2. When you press 4, what came out? 7. When you press 20, what came out? A 1. So for every single point, for every single input, there's one single output. Okay, finally, a question that has. So, let me get this. I'm going to start here and then work myself up. So that's negative 2, negative 6. This point over here is 2, negative 2. This point here is 0, and 0. The next point here is negative 2 and 1 and 2. this point right here is 0 and 4. And the last point over here that it's 2 and 5. I mean, there's so many other points. I mean, there's this point, there's so many, but these are the points that. And 2 and 5, yeah, correctly. So, let me create a table. X and Y. Input, output, right? Remember your input. Your X is always your input. Your Y is always your output. So, let me write -2, -6, 2, -2, 0 and 0, -2 and 2, 0 and 4, and then 2 and 5. We can already see that there might be this might not be a function. So let me get -2, a 2, a 0. I already have a -2, I already have a 0 and a 2. So let me space this out. -2, a 2, and 0, because the numbers repeat, right? So over here I have -6, -2, 0, 2, 4, and 5. All right. -2 becomes 6, so we're okay so far. And then 2 becomes -2, so far so good. -2, then we have -2 again. This time it becomes 2. So when you press -2, you're getting either -6 or you're getting to your 2 outputs, 2 different outputs. That we don't want. 0. Sorry, I forgot the 0. 0 becomes 0. And then we have 0. Look at that. You press 0, you get a 0, or you press 0 and you get a 4. And then we got 2 and 5. There is no way this is a function, because for some inputs, actually for all these inputs, for -2 you have 2 different outputs. You have -6 and 2. For 2 you have -2 and 5. And for 0 you got 0 and 4. So this is not a function. The domain and range. Domain are your x values. Your range. Your y values. Okay, so definitely not a function, because you can clearly tell. Now, talk about a little bit about. Let me create a line here. Straight line. Imagine this straight line. Okay, and I'm moving this across. So when this line is right here, guess what? There are 2 points that touches that line. And as I move this line through this function, notice that the line there's in here, that red line has this point, and this point touching the line. So at any given point in time, if it's a function, you can only have 1 point touching the line, not 2, 3, 4. Okay. All right. 5. Given the map, create a table, a graph. So input. So here's my x. This is always my input. This is my y, which is my output. So for my input, I'm gonna go 1, 2, 3, 4. Those are gonna be by zeros, and then by output, I'm gonna go by tens. So this is 10, 20, 30, 40. So 2 goes to, says 2 goes to 20, which is right here. But 2 also goes to 40, which is right here. 4 goes to 40, and then 3 goes to 40. So you can tell that this is not a function. Why? Because for the input, when you input 2, what do you get? You get 40 and you get 20. There are 2 different outputs for 2. So let's create a table. So we got 2 and 20, we got 2 and 40, then we have 3 and 30, and we have 4 and 40. We got 2 and 20, we got 2 and 40, we had 3 and 30, and we had 4 and 40. What's our domain? Domain are your x values, 2, 3, and 4. What's our range? The range was our y values, which is 20, 30, 40. Okay, so Is this a function? No, because we can clearly see from here, I think that's the best view, that when you press on 2, you actually get 40 and you get 20. You can't have two outputs for the same input. Now, let me talk about a little bit more about the vertical line test. And again, imagine a line. Imagine taking this line across like this from left to right. When it hits right here, guess what's happening? You got 2 points hitting the line. You got this point hitting the line and this point hitting the line at the same time. That is called the vertical line test, and every time you do that and that happens, it's just another way of saying that's not a function. So, and again, if it was just here, this would be okay, everything's okay, it's okay, but here is where it fails the test. So this particular relation is not a function. All right, so which one is not a function, and explain why not. So remember, let's look at it one by one. -3. -3 goes to 3 and only 3, good. -2 goes 6, that's good. -1 goes to 0 and only 0. 0 goes to 15 and 1 goes to -1. This, yes, it's a function. So let me just write it. So this is a function. Next one, -3 goes to -6, that's okay. -2 goes to -6, that's okay. -1 goes to -6, 0 goes to -6, and 1 goes to this is a function. They all go to 6, -6, but that's okay. So if I press on -3, what comes out? It's -6, and only -6 comes out. Every time I press on -3, as long as I have only one answer, one output, that's okay. It doesn't matter that they all have the same output. Okay. C, -3 goes to -6, that's okay. -2 goes to -1, that's okay. -1 goes to 0, that's okay. 0 goes to 3, so far so good. But we have an issue. When we press 1, it goes to 0 and it goes to 15. So for this one, 1 has 2 outputs, and we can't have that. So not a function. Last one's pretty straightforward. Every single number in the domain has one single output. -3 becomes -6, -2 to -1, -1 to 0, 0 to 3, and 1 to 15. Completely a function. Okay? This one's a little tricky. It says, and then, you know what? Maybe you want to do something like this, because I have difficult seeing that. I'd rather write it maybe like this. So we got 12, which becomes 14. We have 13, which becomes 5. We got -2, which becomes 7. And then we have something here that I know, which becomes 13. Right? So they're asking us, what number can we not, can't, let me just write it bigger. Don't put these numbers there. I'm not allowed, because if you put the numbers there, it's not a function. Don't put these numbers there. There should be a big sign. Which numbers can't I put in there? Well, I think it was one of the last problems we sort of talked about in class. If I put a 12 in here, let me change colors. If I put a 12, would that be okay? No. Why not? Because, well, 12 is already going to 14. If I put a 12 here and says it's going 13, I have the same 12, right, going to 2 different outputs. And that's a no, in order, if you want to keep it as a function. So 12, don't put 12 there. There's 2 more numbers I can't put there. Well, the other number would be 13. What if I put 13 there? Well, then if you put 13 there, you're telling the 13 becomes a 5, and then 13 has an output of 13 again. So 13 has 2 different outputs. So that, not allowed. That number is allowed, not allowed. And the other number, obviously, now that you know, 12 can't be it, 13 can't be it, obviously it can't be a -2, because -2 already has an output of 7. And if you put -2 over here, it's gonna say that -2 has also an output of 13, which we don't want, because we want to keep to the function. So -2 is not any other number in this world. Put a 0 in there, that's okay? Yeah, 0 becomes 13. Does every input have a unique output? You're good. So 12, 13, and negative 2, not in there. All right, same thing here. I want this to not be a function. So let me put a point here and call this C. All right, so let me put that in the map. Well, first of all, what points do we have? We have point 3, 5, and the other point 6, 6. So I have to put that in the mapping. I would put 3, I put 6, so 3 becomes 5, 6 becomes 6. Is that a function? For 3, do I only have 5 as an output? Yes. For 6, do I only have 6 as an output? Yes. So that would work, this point would work, this point would work, and so a lot of points. This point would work, this point would work, this point would work. What's the only, it's like there's a location area where these points don't work. And let me show you where they are. Any point over here. Any of those points do not work. Let's prove it why. So let me pick this point right here and call it C. So let's get to our numbers first. So the numbers are 3 and 5. And the other number is 3 and 8. And let's see why this is not a function. If you put a point that's right above it or below it. If you create a map, this is my x value, my y values, right? My domain, my range. So we get 3. And guess what? So let me put x and y so that we know x and y. We have another 3, so I'm not going to write it again because it's repeated. But for y, we have a 5 and an 8. So we're continue our mapping here. The 3 is 5 and the 3 is 8. It's like that soda machine example I told you. We press Coca-Cola. Sometimes it comes as Coca-Cola. Sometimes it comes out of Fanta. If we want this to be a function, that cannot happen. So any number here do not work. So going back to that vertical line test, right? So imagine that those points were it, and I asked you, hey, does this represent a function? Well, you would take this line, draw a line, right? Take a pencil and move it across this. If you move it across, and when it hits this, do I have 2 points hitting that pencil at the same time? Yes, I do, right? In this case, if that happens when you do the vertical line test, it tells you that this is not a function. So what is a possible coordinate of point C that would fit the criteria? So in order for it to not be a function, well, we have point A, which is 3 and 5. Another point would be 3, 8 right here. And if that was the other point, then this would not be a function. Last problem, which of the following lines do not represent a function? So let's do this one by one. And what are my lines here? Okay, a CD. So let's connect C and D. Is that a function? Right? So and this is where the vertical line test comes in very handy for graphs. Right, so pay attention. I'm going to take this as, I'm going to change color of this line. Okay, well, as I move this line here across, right, do they only meet in one point? Yes. They all it's one point only. Okay. Let me try line AB. Where's A and where's B? Oh, here's AAB. Why it's red. Oh, change colors. So the line AB, like if you do the vertical line test and you took this line and moved it across like that, the two lines meet in only one point. So right here, they meet just here, right? They only meet in one point. They intersect in one point only throughout this whole movement left to right, when I move this pencil left to right. Let's try point BD. Well, Where's B and where's C? Here's B and here's D. Uh-oh. Now, if I asked you when I move this pencil, right, this is line BD. Right, so if I were to move this guy over here, how do I change colors? Edit. No. Okay, there we go. So imagine now I'm testing to see if this is a function or not. So again, as long as when I put this line and they meet only one section of the pencil, it's a function. But look what happens when I move this blue line across. They connect in so many places. Right? They connect, now here's green. Look, they connect in more than one point. They connect here, they connect here, they connect here, they connect here. Look. Right? This blue line, when it goes on top of the line BD, they connect in more than one intersection, one place of intersection, many places of intersection. So when BD, right, the relation BD would not be a function. Shoot, sorry. Clear annotations. All right, and the last one, EC. Where is EC? EC is right here. Okay. Line EC. Let me take another line. I don't want to change it. Okay, so I want you to imagine if you were to take this blue line over here and move it to the right, where is there more than one place where the red and blue line meet? Right now, if I stop the pencil, stop the movement, they meet right here, right at that intersection. 1 point only. Keep moving it. And again, if I move it over here, the blue line, the red line meet only over here. If there's only 1 point of intersection as you move this vertical line across the function, then it's a function. If it's more than 1 point of intersection, it's not a function. And that only happened with C. So that was a function, that was a function, and this was a function. Okay? That's it.